Hello, everyone. I'm Dr. Reza Said Kandezi, and in this video, we are getting into a part of engineering where things get interesting. Uh, we are gonna talk about the tech when they meets ethics. Think of it like this: we are not just building machines anymore. We are building systems that make decisions. And that means we've got to ask not just can we build it, but also should we build it like that? Uh, this is where IEEE 7000 series comes in. It's a whole set of standards that helps engineers think about the right way to build emerging technologies. It's not just about how fast something works or how much data it crunches. It's about making sure what we build is actually good for people. Now, we need to keep in mind a few things. One is that this series doesn't replace older ones, older standards like IEEE 1680 or 1547. It's more like an add-on that covers ethics and behavior and social impact. Uh, at the second point, it matters more than ever now because we're working with AI or automation or data heavy systems. So stuff that makes real world decisions. And also, honestly, we are a turning point. We are at a turning point. So we're building systems that are going to teach people, track them, judge them, hire them, or even help heal them. So the ethical side, it matters. Now, back to the main discussion. Engineering standards were all about stuff you could measure, like how efficient something is, or signal quality, safety checks, or data accuracy. And honestly, that worked if it didn't blow up or glitch out, great. But then the technology changed and AI come in, autonomous cars come in, and serialized systems come in. All this stuff that affects people's lives, not just hardware. Suddenly, it wasn't just about making sure the system works. It's about whether it is fair, or whether it respects privacy, and whether it makes responsible choices. That's basically when IEEE stepped in and said, okay, we need something more. So they launched something called ethically aligned design. Okay, a project that help engineers basically bring ethics into the design process. And that's basically what led to IEEE 7000 series. So instead of just checking if the math works, this series help that you check whether the system is respectful or transparent and fair right from the start. Now, here is a big shift in thinking. So, most traditional standards focus on technology. How about IEEE 7000? It starts with the human values. Okay, it basically says that every system we design, whether it's a chatbot, a delivery drone, or a loan approval algorithm, uh, that is going to reflect some kind of priority or belief. So, let's make sure those values are good ones. So, what that means in real life. First off, technology is never neutral. Whether you realize it or not, every system includes choices that reflect what someone thinks is important. So, transparency has to be built in from the beginning. So, people should be able to see how systems make decisions and not just guess. Uh, Also, accountability isn't just a software thing, so it has to exist at a team and organization level too. So everyone involved should know what they are responsible for. Another point is that we need to respect people's dignity and control. So systems shouldn't trap users or push them around. So they should help people make their own informed decisions. Now, let's break down the IEEE 7000 and look what's inside this standard series. Okay, what does this series actually include? So first, there are process standards. These walk you through the steps for making sure ethical stuff is part of the product development process. Now, then there are domain-specific standards. These zoom in on particular issues like privacy or fairness, depending on what field you're in. And finally, there are some emerging technology standards which deal with the new stuff like VR or AI finance, and basically technology that's evolving fast and needs some ethical backup. Now, this isn't just one hard rule book. So the 7000 series is a whole collection of the related standards you can mix and match based on what you're working on. So each one usually includes like a clear definition so you are not guessing what words mean. It also includes design tools like value check matrices, also system diagrams to help you plan, and testing and reporting tools so you can actually verify that you are following through on these ethic parts. Now, all right. So where does the IEEE 7000 series show up in the real world? The short answer is that pretty much anywhere that machines interact with people. If your system uses data or makes automated decision or has any level of autonomy, okay, then yes, this series is meant for you. So let's break it down. So anytime a system is using AI or automation or personal data and is making choices that affect people, these standards are relevant. Also, it becomes super important when the outcome might impact different groups in different ways. Think about that. Like, does it treat everyone equally? Or is there any bias backed in? Okay. So, uh, it's also useful for messy and unpredictable environments like smart cities or self-driving cars or anything where the technology has to deal with real-world chaos. Now, some real-world example is like healthcare diagnostics or smart infrastructure or educational app actually or a surveillance technology, even autonomous defense system. So basically, if people are involved, ethics should be involved too. So that's what IEEE 7000 series is trying to make sure of. Now, let's talk about the structure. IEEE 7000 isn't random. Okay, it's built like a layered stack, kinda like how the internet has layers. Okay, so here's how the ethical stack breaks down. So one, we have three main layers. Each one does a different job in the ethical design process. So layer one is the foundational process framework. This is your big picture method for designing with ethics in mind from day one. Layer two looks at the specific ethical risk like bias or privacy and transparency. It's about a little bit of zooming in on the hot spots. And layer three is for emerging technology, like new stuff like extended reality or algorithmic finance, all the blending edge challenges basically. Now, each layers comes with its own standards. Okay, so IEEE 7000 is for the core process. Now, IEEE 7001 all the way to 7009 is for focused ethical risk. And the IEEE 7 2011 up to IEEE 7015 are for new technology fields. Now, you don't have to use just one. You can mix and match across layers depending on what your project needs. Okay, so it's like a building with a Lego. So take what you need from each layer so you can make sure the system is ethically solid. Now, let's zoom in IEEE 7000. Okay. Uh, Basically, this IEEE 7000 gives you a full process for figuring out the values that matter and turning them into the actual engineering requirement. Now, here's what is included. So it helps you figure out which people are affected by your system and what they care about. So through something called stakeholder engagement. Also, you'll make stakeholder maps and do impact modeling. So basically diagrams that show how your system connects to the people's lives. On the other hand, you take those values like fairness or dignity or privacy and translate them into like design requirement, like things you can build or measure and test. Now, the ethics checks are not just once and done. Okay, IEEE 7000 says that you need to keep checking through the whole system life cycle. So make sure those values stay in place. It doesn't tell you what's right. It gives you a clear method to bring other people's value into your engineering work. So the outcome would be you get a traceable stuff like value profile and ethical requirement document that prove you follow the process. So great for governance and accountability. Now, IEEE 7000 is the process, but there are also individual standards for specific concerns. Like here are a few big ones. The IEEE 7001 is about transparency in autonomous system. So it says that the system should be able to explain their decisions in a way people can understand. Now, IEEE 7002 covers data privacy. It basically guides you on how to collect and use data, basically responsibility. So using things like a consent workflow or privacy tools. Now, IEEE 7003 handles the algorithmic bias. So it teaches you how to measure the bias or fix it and keep your system fair. And another example is IEEE 7010, which shifts the focus on well-being. So it helps you measure if your system is helping or harming people's mental or physical or social health. Now, each one of these standards targets a different issue, so privacy, fairness, or transparency or well-being. So it gives you practical ways to handle those concerns. So depending on what kind of a system you're working on, these are some plug and play ethics tools. Now, let's talk about some key ideas around that explainability. This is what helps people trust and understand the system. Okay, so explainability is just what it sounds like. Your system should be able to say, here's what I did that. Okay, here's why I did that. Now, the goal is to make decision to make sense for humans. Now, traceability means you can look back and reconstruct every step that the system took, like decision breadcrumb trails. On the other hand, we have predictability, and it's about keeping behavior consistent so user can know what to expect. So no random surprises or weird actions. We have auditability, means someone outside your team should be able to go in your system and check what happened. This helps basically with the regulation and trust. Now, also we have disclosure means that means being upfront about what your system can and cannot do, what it's limited by, and how it might basically behave. So no hiding behind the code. These five ideas help build trust in technology that makes decisions, and they are a big part of what IEEE 7000 is pushing for. Now, let's look at how we can make systems uh, not just work, but be transparent or trustworthy and accountable. Now, we have decision logging, which every time the system makes a big choice, it needs to record what happened. This includes inputs, conditions, and its own internal state at the time. Basically, keep a time-stamped notebook of every decision so we can go back and see what it was thinking. We have signed logs, which is those logs should be cryptographically signed. So, like putting a tamper-proof seal on each log. So that way you can prove nothing been changed or messed with later. Now, explanation interfaces are the tools that help different people understand the decision. So developers might need full logic traces, uh, while user just need a clear sentence or two explaining what happened. We have model transparency reports that are some summary documents that explains how the system works or what data trained it, where it struggles, and so on. So think of it like a user manual for regulators or researchers and anyone else checking under the hood. Okay, so put all this together and now you get a setup where users can trust what's going on and engineers can back up their decisions. Now, let's talk privacy. IEEE 7002 is all about making sure that the user data is respected and protected. And it breaks things down into clear principles and steps. Now, the big idea is uh, one, privacy principles. These include things like collecting only what you need or being clear about why you are collecting those information and giving the users control, also being honest and keeping things in the proportion. Now, it's about doing privacy the smart, respectful way, not just the legal minimum. Now, how do you make it happen? Now, IEEE 7002 gives you a workflow. Okay, so first we have context mapping. In that part, we figure out who's involved, what data is being handled, and where treats might come from. Okay, so on the other hand, we have data flow analysis, which track how data moves through your system from the entry, okay, to the storage to the deletion. Now, we have requirement and specifications. That part write down exactly what privacy protections are needed based on user values or laws and the tech constraints. After that, we have control design, which we are choosing tools like encryption or access control or differential privacy to actually protect the data. We also have some verifications. Okay, so these steps test your controls and keep checking that they work as the system evolves. Now, it also helps make sure your system aligns with the real world law like GDPR or CCPA or HIPAA. So it's not just good practice, it's actually legally smart too. Now, let's go a little bit deeper into how the privacy design process works. Now, this is the step-by-step process. We have context mapping. So first, we have to figure out what world your system is operating in, who is using it, what data is involved, okay, and who might try to attack or misuse that data. After that, we have to do data flow analysis. This is when you trace how data travels, like when and how it's collected or stored or processed and deleted. Okay, you're looking for spots where privacy might be at risk. Next step is the privacy requirement specifications. This one take the values from users and the rules from the regulators and turn them into the hard requirement. It is not just the vague ideas. So in the next step that we have control design and selection, we could set up the system based on the risk that you pick specific security tools like encryption or anonymization or whatever makes sense. At the end, we have verification. Okay, so we have to make sure that all works. We have to test it, we have to audit it, and if there is a problem, fix it, and it should be repeated continuously. The whole thing isn't a one-time deal, it's something you look through as the system grows and changes. Now, let's talk about bias. Systems don't have to be like evil or they don't have to be evil to be biased. Okay, they just have to be built on a bad or incomplete data or designed without realizing who they might unintentionally hurt. So IEEE 7003 gives you the tools to spot and fix that. Here's how. Like we have bias risk assessment. This is start by looking for the usual suspects like sampling bias or label bias or measurement bias and even automation bias. Basically anywhere an unfair assumptions might sneak in. Then we have mapping data and intersectionality. Okay, so this studies how data flows and how different social identities like race, gender, or age might interact to create a compounding bias. In model level bias testing, uh, that part use math to check the fairness. Things like demographic parity or equalized odds or predictive parity. These gives you a quantitative ways to evaluate the bias. Now we have subgroup analysis that breaks down the performance by group. So see if your model is working better for some and worse for others, which we have to fix it if it is. Now we have bias drift monitoring, which we have to keep watching even after the launch. So bias can change over time, especially when we are dealing with a learning system. We have a real-time fairness dashboards plus the appeals. So this is a build tool so people can see the fairness metrics live and challenge the bad decisions. We have to have full documentation that keeps model cards, data sets, data sheets, and your design decision, which are well documented. That way, everything is traceable and explainable. Now, this all helps you build a system that don't just work, they work fairly and responsibly. Now, let's talk about the nudges. A nudge is basically a small design trick that steers people in a certain direction without forcing them, like a setting a good default or giving a gentle reminder. IEEE 7008 basically steps in to say, okay, nudges are powerful, so let's make sure they are used ethically. Here is what it wants you to keep in mind. First, a nudge should influence behavior without taking away choices or adding pressure. Okay? Think about a default opt-in to email updates. They should not locking you in. Now, ethical nudging means being transparent about what the nudge is doing, then respecting the people's freedom. After that, we have to make sure that effect is proportionate and keeping it user centered. And at the end, we have to making it easy to undo. Now, IEEE 7008 also breaks the nudges into the risk levels. We have low risk nudges like a friendly default settings, and we also have high risk nudges like hyper targeted nudges based on personal data. The more intense the nudge, the more security it needs. Okay, and it needs more scrutiny. Also, when we're talking about the high risk, and one final test: who's who benefits from those nudges? If the nudge is good for the user, great. But if it just helps the company to sell more stuff, you need to ask whether it's ethical or not. Now, no system is perfect. Stuff will break, so the question is what happens when it does? So IEEE 7000 has some solid ideas about that. We have graceful degradation. So if your system starts failing, it shouldn't just crash or act unpredictably. It should scale back safely, maybe lose some features, but still stay safe and under control. We have also ethical override, which is when things go really wrong. The system needs to prioritize people's safety and the values, not the optimization or speed or profit, even if that means slowing down or shutting off the system. The state awareness is about the fact that the system should know what's going on with itself and the world around it. So if something changes, like a sensor fails or an external risk shows up, it should adapt on its own. Now, we have interruptibility, which is a human or external system should always be able to hit pause or stop. There should be no drama or confusion. So if we can interrupt it, we don't really control it. Remember that. Now we have also post-failure forensics. So after any failure, there needs to be a clear record of what went wrong. So teams can trace back the cause and fix it and learn from it. So logs, system states, timelines, all should be saved and ready to analyze. These ideas basically make sure that the system fail actually safely or ethically and with accountability built in. Now, let's flip from failure to something more human, which is well-being. IEEE 7010 helps you to measure how a system affects real people's life and is not just through efficiency or speed. So they actually give weights to different areas of impact, okay, like mental and emotional health, which has a weight of 25%. Okay, basically, is your system causing stress or anxiety or confusion, or is it making people feel better and more stable? Okay, we have physical health with a weight of 20%, which asks, does it help people physically? Does it avoid harm or support safety or reduce physical strain? We have autonomy and control with a weight of 20%. This part asks, do users stay in control or can they make their own choices, or are they being pushed or tricked or overridden? Okay, so fourth part is social connection. This part has 15%. In this part, we ask that does it help people connect or does it isolate them? This includes like community support, collaborations, or even just feeling seen. The skill and purpose is another factor. That one has 10% weight, and basically it's about does the system help users learning things or grow or feel accomplished or do something meaningful. Now, when we talk about the economic security, which has a 10% weight also, we are talking about the fact that does the system protect people financially? Does it open up opportunities or put them at risk? These stuff aren't just fluff like metrics. They are built to help you evaluate the human impact of the technology in real and structured ways. Now, last one for now. This slide ties everything together. Think of IEEE 7000 as a multi-layered ethical system where each layer tackles a different part of a technology experience. Now we have policy and process layer. This is where all it starts. So we figuring out stakeholders' value or doing a mapping and building your ethics process from the ground up. When we talk about the data governance layer, this one covers privacy and data ownership and security. It's about protecting the data that people trust you with. In decision logic layer, this is the AI algorithm part. It makes sure systems are fair, transparent, and explainable. So no black box surprises. There is a safety system layer which focuses on how the system behaves when something goes wrong. So it should be fail safes or overrides or reliability into the system. Now, lastly, we have human outcomes layer. This one makes sure that the final result of the system is basically good for people. It could include like well-being, dignity, autonomy, and so on. Now, all these layers are connected. You can't build ethical tech by just patching in one piece. They all influence each other. So the big takeaway is IEEE 7000 is not just a checklist. It's a framework you build into your system from the start to finish across design, development, and the deployment. Now, here's our discussion about this IEEE 7000 series. If you have any question, please let me know. Otherwise, thank you for your attention.